Get ready to witness the incredible power of Mother Nature in this video. We'll be uncovering the largest explosion ever recorded in history and the impact it had on the world. From the initial blast to the long-lasting effects, this event has captivated scientists and historians for years. So join us as we dive deep into the details and explore the fascinating story behind this explosive event. The biggest known explosion. The biggest known explosion in the universe has been spotted by astronomers, and it was so intense it punched a crater the size of 15 Milky Way galaxies into a part of space hundreds of millions of light-years away. Scientists say they've never seen anything like it. According to a study published Thursday in the Astrophysical Journal, astronomers discovered the record-breaking eruption using X-ray data from several sources, including NASA's Chandra X-ray Observatory and ESA's XNM Newton, and radio data from the Murchison Wide Field Array, MOA, in Australia, and the Giant Microwave Radio Telescope, GMRT, in India. It was so massive, they have little to compare it to. In some ways, this blast is similar to how the eruption of Meek Street Helens in 1980 ripped off the top of the mountain. Lead author Simona Santucci of the Naval Research Laboratory in Washington, D.C. said in a press release Thursday. A key difference is that you could fit 15 Milky Way galaxies in a row into the crater this eruption punched into the cluster's hot gas. The energy that created the explosion was about 5 times greater than that of MS 735 plus 74, which previously held the record for the largest explosion in the universe. Scientists sourced the burst to the distant Ophiuchus galaxy cluster, which is about 390 million light-years from Earth. According to NASA, galaxy clusters are the largest structures in the universe, held together by gravity and containing thousands of galaxies, dark matter, and hot gas. Researchers believe the origin of the explosion is a supermassive black hole in a large galaxy at the center of the Ophiuchus cluster. While black holes are known for dragging material inwards, they can also blast material and energy outwards. In this case, the black hole blasted out jets that created a huge cavity in surrounding hot gas a few 100 million years ago. Astronomers first found evidence of the gargantuan explosion back in 2016, but they detected a cavity so large they thought it was impossible. With the help of new MOA radio data and archival GMRT data, researchers confirmed the cavity and found the explosion that created it. Record-breaking burst. In our paper, we considered the possibility that the feature is a result of a record-breaking black hole outburst, but we discounted it as unlikely. This is one of the nearest galaxy clusters, and it appeared to be too much of a coincidence to see such an outburst in our cosmic backyard, he continued. Extraordinary claims need extraordinary evidence, and the observation reported in this paper provides the evidence that we lacked. Both observations spotted an unusual curved edge in the cluster that turned out to be part of a massive cavity created by the explosion. The radio data fit inside the X-rays like a hand in a glove, said co-author Maxim Markovich of NASA's Goddard Space Flight Center in Greenbelt, Maryland. This is the clincher that tells us an eruption of unprecedented size occurred here. Scientists said the explosion is no longer happening since new data shows no current jet activity. The gas that once fueled a black hole for its growth and jets has likely moved on to another galaxy. This has been like discovering a dinosaur, with just a little piece, the unusual X-ray edge, sticking out at first, and then suddenly a new kind of creature coming out from the ground. It is possible that comparing radio and X-ray cluster images will soon unearth many more such dinosaurs. There is still one mystery that scientists have yet to piece together. Typically, jets blast out from both sides of a black hole, but radio emissions are missing from the other side. As is often the case in astrophysics, we need multi-wavelength observations to truly understand the physical processes at work, said Melanie Johnston-Hollett, a co-author from International Center for Radio Astronomy in Australia. The combined information from X-ray and radio telescopes has revealed this extraordinary source, but more data will be needed to answer the many remaining questions this object poses. We don't know exactly how powerful this burst is, though, even though many telescopes around the world are looking at it. That is partial because it is so bright that it saturates the detectors of gamma-ray telescopes. So all they see are completely white pixels with no detail, says Andrew Levin at Radboud University in the Netherlands, one of Rasteenjad's colleagues. If you had gamma-ray eyes, you'd be blinded, he says. Current estimates put the energy of the GRB between 10^54 and 10^55 ergs, he says. In contrast, the total energy released by the Sun throughout its lifetime is expected to be about 10^51 ergs. GRB 221009 is so bright that it is affecting Earth, even from billions of light years away. Naval radio transmitters recorded a strange disturbance in the upper atmosphere, which seems to have been caused by the powerful light from the GRB slamming into it. Detectors that search for high-energy photons, particles of light, have also seen extraordinary particles with energies far higher than anything produced at the Large Hadron Collider. This has made a splash among astronomers. It seems like pretty much every telescope in the world is starting to look at it, says Ristine Jad. But to learn more about this supernova itself and its home galaxy, they'll have to wait until the bright jet fades, which could take months. Once that occurs, we should have a better idea of why this GRB was so extraordinarily bright. This type of gamma-ray burst, GRB, is thought to occur when a massive star explodes in a supernova, leaving behind a black hole. The explosion creates an extraordinary jet of light, which makes up the GRB itself, and then the supernova causes a dimmer afterglow. This particular GRB appears so bright partially because it is about 2.4 billion light-years away from Earth, making it one of the closest GRBs ever spotted in addition to being the brightest. As we come to the end of this video, we hope that you've gained a better understanding of the largest explosion ever recorded in history. It's amazing to think about the sheer force and energy that was released during this event and how it shaped the world we know today. While the power of nature can be awe-inspiring, it's also a reminder of the importance of taking care of our planet. Let's work together to preserve our world and prevent similar catastrophes from happening in the future. Thank you for watching, and until next time.